All right, this is lesson 3 of unit 4 on translations on the coordinate plane. Another type of rigid motion is a translation. Remember, a rigid motion preserves length and angle measure. Translations also called a slide, in which every point of our figure is moved the same distance in the same exact direction. So if you just look over at the graph that's already graphed for you, to describe how to translate triangle ABC to its image, triangle A prime, B prime, C prime, we're going to look at each point of this figure. So A, we notice it's going to the left, 1, 2, 3, 4, 5, 6, 7, 8, and down 4. If you look at the rest of the points, point B, that's also going to the left 8 and down 4. C is going to the left 8 and down 4. So every point in this original figure is translated to the left 8 and down down 4, I should say. Okay, we can write this using two different notations. So an uppercase T represents a translation. So we can write it as T of -8, -4. So to the left, that means negative, down negative. So we still work in our coordinate grid with that. Or you might sometimes see it as X, Y, so that coordinate, and then you'll see an arrow, means translates to X -8 and Y -4. So that tells you that you take every X value in your original figure, subtract 8 from it, and every Y value, and subtract 4. Is the size of the object preserved under your translation? If you look at this original triangle and you look at the image, you do see that the size is preserved because all you're doing is you're taking it and you're sliding it over. So yes, size is preserved. The orders of the vertices is the same, meaning here we went from A to B to C in our counterclockwise direction. We still do that here, A prime, B prime, and C prime in a counterclockwise direction. So yes, the order of our vertices are preserved. The last thing here says, using rays, connect the pre-image points with the image points, and what do you notice about the rays you have drawn? Okay, so I'm going to start with point A, and I'm going to draw to A prime, a nice straight line. I'm going to start with C, and I'm going to draw to C prime, and same thing with B to B prime. I notice that all of these rays are parallel, and that they all are equal in length. All right, some vocabulary that we need for this lesson. An isometry is a transformation that does not change in size. So the same thing as a rigid motion, doesn't change in size. So this includes all of our rigid motions. Reflections, which we talked about already, translations, and rotations, which we will talk about. A direct isometry then preserves size and the order or the orientation of our vertices. So the order of our vertices is called the orientation, and that's what we talked about up here. An example of this then is our translation. So the translation preserves the order of our vertices. An opposite isometry preserves the size still. So all isometries preserve size, but the order of the vertices change. So if you remember from yesterday with our reflections, the order did not always stay the same. If you had triangle, let's see, ABC here, and we're reflecting it over this line, this would be A, this would be C, and that one would be B. So if you go in order here, we have A, B, then C, but even if we start at A here, we go A to C, where over here we went from A to B, and then C to B, where here we went from C to A. Okay, so the order of our letters are not the same for a opposite isometry or a reflection. All right, so on the coordinate grid, it's easy just to go ahead and count your translation. A general rule for it here is translation of A, B. A and B in this case are just some numbers, so like 2, -3, or 0, 4, whatever, of x, y. All you do is you take your x coordinate of your point and you add whatever A is. You take your y coordinate and you add whatever B is. So that's your general translation rule. We're going to try a few examples where we don't have the coordinate grid in front of us, but we're still going to use our translation. So determine the coordinates of the image of point 5, -3 under translation of t, -2, -1. So when you do that, you're just going to take that 0.5, -3, our x value is 5, and I'm going to subtract 2 from our x value, and I'm going to subtract 1 from our y value because that's what this is telling me. So that means that the image of that point would be 3, -4. Okay, determine the coordinates of the image of the point -8, -3 under this translation, and your notes have a negative in there. That's just another way to write it, remember. So we're going to take -8, our x value. We're going to add 4, take our y value, and subtract 1. So this would be the same thing as -4, -4. So that's the image of the point -8, -3. All right, number 3 says determine the translation that maps the point -5, 5 to the point 7, 1. So instead of telling us the translation, it wants us to figure it out. So I'm just going to sketch it. So -5, 5 I'm going to say is about there. And the point 7, 1 I'm going to say is about there. Okay, so our x value, we need to know how far we're traveling to the right. So we know it's a positive because we're going from -5, 5 over to 7, 1. So the distance from -5 to the y-axis is 0. From there all the way over to this point is 7. So the total distance is 12 units to the right. And then we need to figure out how far down. So from 5, which is our y value, to 1, we're traveling down 4 units. So we're going to say 12, -4. Or you could write it as xy goes to x plus 12 and y minus 4. Either of those ways to write it is fine. All right, the last one that we have here is a translation maps the point -2, 5 to the point -4, -4. And then we want to know what is the image of 1, 4 under the same translation. So first we have to know what the translation is. So again, I'm going to sketch it to help me see it. So -2, 5, I'm going to say is about there. And -4, -4 would be down here. All right, so my x values, I'm moving to the left, so I know it's going to be negative, and I'm going to the left, -2. So my translation is -2. My y value is going down, so it's also going to be negative from 5 all the way down to -4. So that's a distance of 9 units down. So this is -2, -9 is my translation. Now I'm going to look at the point 1, 4 and do that translation of -2, -9 to that point. So I'm going to do 1 minus 2 and then 4 minus 9. So the image is -1, -5, and that would be your answer.